Well, it's great to be here with you this morning. Like Jingy said, my name is Hava. I'm a soil scientist and the current leader of the SnapPlus program based here at UW-Madison. And in our brief time together today, I want to cover three things. One is a short introduction to SnapPlus in case you're not familiar with the program or how it's used. And then I'll do a high-level overview of our Wisconsin Phosphorus Index model, which is an important model that's incorporated in the SnapPlus program. And at the very end, I'll give an example of a way that we're able to collaborate and use research to improve the model over time and help us understand and better predict phosphorus loss from Wisconsin agricultural systems. So what is SnapPlus? SnapPlus stands for Soil Nutrient Application Planner Plus, and it's Wisconsin's nutrient management planning software. And I'd say this is a great example of interagency cooperation through time that Wisconsin has had a free nutrient management planning software funded by the agencies you see here on the screen, housed and developed here at UW-Madison for more than 20 years. So we build this program for use by farmers and crop consultants and many other people, and it's been available for a long time. And in a very broad terms, what SnapPlus allows users to do is try to solve this nutrient management puzzle in a very practical way. So when we have manure to apply, SnapPlus helps to logistically figure out where can we apply this manure given the fields that are available. We're also tracking how farmers can use manure and other nutrient sources to meet the crop nutrient needs based on UW nutrient requirements without exceeding recommendations for nitrogen and phosphorus. And finally, an important piece and a somewhat complex piece is helping users with nutrient management plans follow the various and interconnected application rules to make sure that we're keeping fertilizer and manure in the field with the crops and not losing them to local water sources. And that all ties back to the NRCS 590 nutrient management standard. So SnapPlus as a software tool is helping do all of these different things. And we have a history of more than 20 years here of providing this tool and evolving this tool to try to make it more useful to farmers and farm operators across the state. So back in 2005 was our very first public release, essentially a glorified spreadsheet. And then as we move through time, you can see we're adding features to this software tool related to regulatory components. How can we flag different important restriction features in fields based on geospatial data? And then our graduation to a full-blown desktop software right around 2013. And one of the biggest things that our team is currently doing with a lot of help is transitioning to a web-based software that we call SnapPlus version 3. So that we launched last year and has been a major project of updating not only the software interface, but a lot of the underlying models and data and improving the way that this can be used and be relevant on Wisconsin farms. So for nutrient management planning, some of the most common users of SnapPlus would be farmers, crop consultants. We have county conservation department staff who play a big role in nutrient management planning, and many other agency staff. And just to give you an idea of how many people are using SnapPlus, I'm showing some data here from DATCAP about nutrient management plans that were submitted to counties in 2022 and 2023. And if we look at that first row of nutrient management plans reported, you can see we're talking about 7,500, 7,600 plans. And although SnapPlus is not used for every one of those, it's used for probably the majority of those nutrient management plans. So we know we have thousands of farms and plans in the state that are benefiting from having this software tool. I want to give a quick shout out to the SnapPlus team, some of whom are sitting among you today. So it's not just myself, but we have some software engineers and developers who work hard behind the scenes to build this software and maintain it. And I want to give an honorable mention to two recent retirees from our team who've left within the last year, Dr. Laura Good and Rick Wayne. So in addition to our move to the web, another one of the big updates and improvements we've been able to make with SnapPlus has to do with the evolution of map technology and geospatial technology. So we evolved from the earliest days of when Web Soil Survey first became available in 2005 to working with an online GIS interface for users. We received some Dairy Innovation Hub funding for a mobile app related to manure application, and now we have a fully integrated mapping part of our new web app. So one of the things I want to focus on today is one model that's included within SnapPlus called the Wisconsin Phosphorus Index. And the Phosphorus Index is a quantitative model that estimates phosphorus delivery to the nearest surface water. And so when we think about this model, we're looking at phosphorus in the dissolved form and in sediment or particulate form. And then we also want to account for how much phosphorus is actually being delivered when you go from the edge of the field to that nearest water body. And so in broad terms, one of the important things about this model is that we need to restrict ourselves to inputs that are already part of people's nutrient management plans or that are easily available based on map data or other sources of data that allowed us to get at this number. Because we want this to be integrated into the software program and not present an extra burden when we're using this tool to help us understand and estimate how much phosphorus might be lost based on the management practices and the manure and the fertilizer that's being applied. So I am the current maintainer of this model, but I just want to emphasize that this has been an evolving model with a lot of contributions, not only from my predecessor, Dr. Laura Ward-Good, but from other faculty in biological systems engineering, Dr. John Panuska, a lot of help from Dr. Peter Vadas with USDA ARS, and then important contributions from the late Larry Bundy from the Soils Department. So over time, our goal is to take field research and lab research and small plot research conducted around Wisconsin and use it to improve this model. And an important thing to understand is that the phosphorus index model is actually called out in Wisconsin's 590 nutrient management planning standard. So it is one way that when you're writing a nutrient management plan, you can illustrate that you're identifying the lowest risk places to put manure. So if you've got to spread manure, how can we identify places that we're at least risk of losing that phosphorus? And this model is one way to do that provides some flexibility. At a very high level, when we look at how this model is structured, some of the different components, again, we're breaking phosphorus into the particulate and the dissolved form. And the general form of these equations that I'm showing up here are that we have a transport component, which is in blue, and then we have a concentration component, which is in black. So we're trying to get at this idea of how much particulate and dissolved phosphorus is getting to the edge of the field, and we'll leave the delivery part out of this conversation for now. And this way of setting up a phosphorus index or phosphorus model is pretty common. Wisconsin followed Iowa and Minnesota in the early 2000s in setting up the general structure of these equations. But one thing that is unique about our model is the way that we're treating the manure and the fertilizer contributions to dissolved phosphorus, following some of Peter Vadas's work on those. So looking at the proportion of runoff to precipitation and the concentration or availability of soluble phosphorus from manure and fertilizer to estimate for each season how much phosphorus is being lost in that dissolved form. And over time, we've been able to benefit from a lot of research data, a lot of field research to help us test this model. So I'm showing one example here on the screen from a paper in 2012 that was published by Dr. Laura Ward-Good and others. And here we were able to use 86 site years of edge-of-field monitoring data to answer the question, how does the Wisconsin Phosphorus Index do in predicting total phosphorus lost in terms of like pounds per acre per year compared to what we can measure or monitor on these sites? And what this graph is showing is we've got a slope that's pretty close to 1, meaning that in general, when we're able to use those true like measured precipitation data and sediment data in our phosphorus index equations, we are getting a pretty good fit. We're getting a pretty good estimation of how much phosphorus is actually leaving that field. And this data from 2012, a lot of the things that were learned from this study and the evaluating these 86 site years in the phosphorus index have now been incorporated into the most recent iteration of the phosphorus index that's been released in our web app. So it takes some time to go from this process of publishing research and incorporating research from this edge of field data, and then when we make those updates in the software program, those are reflected for all the users of SnapPlus. An active area of investigation and update that I don't have time to talk about today is our revisions to how we're estimating winter runoff, which is a really critical part, especially in Wisconsin with our climate. That's a winter period is a time when you can really lose a lot of phosphorus. And so I want to encourage you to go see Emma Strickland's poster. She's a master's student in biological systems engineering, and she would love to tell you all about our new winter runoff methods and how we're improving them. So in our remaining time together, I just want to give an example that I think has some relevance to dairy cropping systems about how we can take field data and use it to assess the Wisconsin Phosphorus Index. And what are we learning and how can that sort of illustrate ways that the phosphorus index can be used for decision making when it comes to different management practices that are used on farm, and when people are writing their nutrient management plans, how can that be a tool that helps make those decisions? So this is all data coming from a paper that's currently in press, and I want to acknowledge my co-authors that are on the screen here. So what we were able to do is take advantage of two separate paired watershed experiments that took place at the Marshfield Agricultural Research Station. And at the station, there are set up four watersheds that are experimental watersheds. They're about 1.6 hectares each, and I have a little diagram of them here. And each of those watersheds is outfitted with a monitoring station to collect runoff and sediment. And what we were able to do is take a look at two different experiments. One was in corn silage and one was in different managed pasture. And at these experiments, the researchers were looking at a few different types of treatments, a few different management variations on the corn silage system and on the perennial pasture system. So here I'm showing 4 bullet points, which would be the 4 treatments on those watersheds, looking at different timing of manure application and different application or incorporation method. So you can see that we have a cover crop as part of one treatment. We have sometimes manure applied in the fall or in the spring, and sometimes it's a surface applied or incorporated. So this experiment took place from 2009 to 2011, and they collected edge of field monitoring data at those 4 watersheds. The second experiment is the perennial pasture and hay. So this happened later, but on the same 4 experimental watersheds. And here we have control of a hay crop with liquid manure applications, and then 3 different types of stocking methods, looking at stocking heifers on those pastures and doing the same type of monitoring. So what we were lucky to be able to do was take advantage of some of this data that they collected from these watershed experiments and use that as an input to say, when we compare a Wisconsin phosphorus index estimation of these types of systems with what they actually measured on site, how does that line up? And so I have a few plots to just illustrate that. If we look on average, saying the corn silage system and the pasture system, the plots here are showing that we have WPI is the bar on the right side, that's the Wisconsin Phosphorus Index, and then measured would be that monitoring data. So a good thing to know is that in the Wisconsin Phosphorus Index, because we're always looking ahead, we don't know that year's data or that year's weather in advance. So the WPI here is using the county average temperature and precipitation information. But the takeaway from this particular plot is that in general, when we look at corn silage and pasture, we're getting the approximate distribution of dissolved reactive phosphorus and particulate phosphorus about right. So we see that the corn silage system, phosphorus loss is dominated by that particulate phosphorus, but in the pasture system, we're seeing it's dominated by that dissolved fraction, and that it's in general less phosphorus loss on the pasture system. So that's as expected, and we're encouraged to see that we're getting that approximate distribution between the dissolved and particulate right. The other question we wanted to ask was, when we dig more into some of those specific management practices that I described earlier, here's an example from corn silage, is the Wisconsin Phosphorus Index giving us some idea of the relative benefits of those different management decisions within a given system? So in the corn silage example, we have a control where we have a fall manure application that's chisel plowed, so it's incorporated. And then we have, and that would be at the top here where I have the control with the star. And then we also have a treatment that involves a buffer or a grass filter strip, and that would be at the very bottom. So what we can see in both the monitoring case and in the Wisconsin Phosphorus Index case is that we're tracking that reduction in phosphorus loss that is benefiting from the buffer. So we're able to sort of see the benefit of that practice that is in reality, so in measured on the left side, and then in our modeling on the right side. So that is an encouraging result, because it means that when people use SnapPlus and they are entering information about their management and about different manure applications, they can use it as test out different scenarios to say, what would be the relative risk of phosphorus loss if I make this choice, if I'm applying manure during this season or with this method? And what we're seeing from comparing our monitoring data with the modeling data is that we're approximately tracking that relationship in that case. And then the final example I want to give has to do with the timing and application method of manure. So in this example, we have the same control with that fall manure that's chisel plowed in. And then the comparison that I'm making on the third bar is to a treatment where the fall manure was surface applied, so it was left on the surface through the whole winter, and then in spring it was chisel plowed. And the interesting thing here is that we're also tracking the increase in the dissolved fraction that we see when you leave the manure on the surface all winter. So that makes sense, right? If you put the manure on in the fall, you're leaving it on the surface, you have that manure is in contact with snow and with meltwater. And so what we're seeing is we're seeing an increase in the fraction of dissolved phosphorus there, and we're tracking that with the Wisconsin Phosphorus Index too. So after giving these phosphorus index examples, I sort of want to expand our list of who uses this phosphorus index specifically in SnapPlus. So it's an important part of nutrient management planning as writing a nutrient management plan, but we're also seeing farmer-led watershed groups, water quality projects that might be pursuing water quality trading using this. The DNR's TMDL program uses the phosphorus index, and then some other examples of pay-for-performance research projects and decision support tools like Grayscape and SmartScape, which are also projects at UW-Madison. So this tool, because of its ability to incorporate management information that's field-specific and to be tracking these different impacts of management on phosphorus loss, has utility for more than just writing nutrient management plans. So I want to thank you, and I know we have time for questions after the next presentation.